Okay. So again, object keys quoted are fine. As long as, well, you have to be careful of when the quote starts and when the quote ends, right? If you close the quote after the colon, then that's invalid syntax. Okay, so we have question 6, 7, and 8. Let's see how. Could some of the people who did question 6 post it on Slack so that we review it rather than me writing it from scratch? Maybe Cameron, could you share your question? Okay. Thank you, Brianna. Oh, this is the people who came late. I took note of you. Some of them I didn't catch. Okay, so I'm going to from here just to touch objects review. And then we're going to open that with code. Yeah. Okay, so let's see what the question was asking. Question 6, you're given an array of objects. Oh, I have to copy this as well. Let's copy this first. And then this array of peoples, right? So this could very easily be the array that we created with all your names, like from the class. This is basically, we just had more extra keys, but this will do. Okay, so I have that, and then you're saying you're given an array of objects. Each object in the array contains exactly 2 keys, first and last name, and I'm missing the prompts. Let's do this here. So this is create an array of strings called first names that contain only the values for first name. That will be A. And B is create an array of strings called full names that contains the value for first name and last name from the object separated by a space. So, Camille, for instance, in this one, we have this array of objects, right? And then it's saying create an array of strings called first names that contains only the values of first name from each object. So what would that look like? Let's see. So the first first name is Calvin, right? So this is something also that some of you are already doing, which is always try to talk as to what the output should look like. Sometimes it's really clear in the prompts. For instance, here I think it might be clear, but if it's still not clear, just try to come up with what you think should be the output of your program. That's going to help you have a more clear goal in mind as to how guide you as to how you could get it. How could you solve it? So for the first one, the output should be Calvin, Gary, the etc. Right? Only the first names, etc. Right? Now for the second one, what should it look like? Actually, I mean B, for point B. An array of strings, okay. Calvin for the first one. Newton is their last name, and then it says separated by a comma, right? Newton. Right, and then let's do the second one, Gary. Mackenzie. Okay, etc. Right? Okay, so let's see what Brianna said here. She has an array, full names, and then she has a for loop that is going to start at 0. Is going to go for as long as I is less than people.length. This is to say that it's going to loop as many times as objects in the array. I'm saying the same thing. And we're going to increase I by 1. Now we have first names, which I think I'm missing here. That first names we start full names as an empty array, first names as an empty array, right? This should be here. Now she has first names dot push the array people at index I, right? And for the first one, we're only interested in the first name, so we just do dot first name, right? So these people at I is going to be, as the loop goes iterating, a different object in the array of objects. Is that clear? Okay. These people at I, as the loop goes iterating, will be a different object from the people array. So these are objects, right? So at some point when I is 0, person at I is going to be this person. When I is 1, person at I is going to be this person, and so on. Okay, so we put that in. We just grab their name by using the dot notation. And what do we do with that? We just push 2 first names. This should be somewhat familiar to us now. We're pushing the first name. Now, for the full name, we want the first name and the last name separated by a comma. So if we look at this part, these 2 lines are very much the same, right? We are accessing the people at index I, and we're grabbing their first name. And what are we doing with this here? Right. And what is that action call, like the technical term? Douglas? Concatenating or concatenation. Right, we're concatenating the string that is the first name with a space, followed by, again, we're concatenating their last name right after the space. So when we do console log first names and console log full names, let's see that here. Node objects review. Now we have, let's see, we have all the first names in the first array, like Calvin, Gary, Leah. That's this one. Does this make sense? And then in the last one, full names, we have their full name, not only their last name, but not only their first name, but we concatenated that with not an empty space, a space string or the string space, followed by their last name. So I think some of you might have done 2 different loops. Who did 2 different loops? Raise your hand if you did 2 different loops. Okay, that's totally fine. It's totally fine, but you could see here, as Brianna showed us, that it could have been done in one because we're visiting the same objects again, right? For the for loop, you're still visiting the same objects, so it could have just been done in one. And this is something that we develop with practice as to, oh, I'm kind of doing the same thing, or I'm doing this already here. Let's just include this other part that needs to be done. Cool. Any questions about this one? Okay, let's move on to number 7. Number 7 said, print the second most common letter in the string below. So let's copy all this. Let's put it in code. Yeah, Cam. Sure. But wait, before you need to, before we see your code, what was your approach? Okay. Okay. So the approach that Cam was describing is he's going to count with the help of an object how many W's we have in this string, how many E's we have in this string, even how many quotes we have in this string. On the alphabet, okay. Yeah, so that's something that we could do. We could ignore or acknowledge the quote as one character, right? But it doesn't make a lot of sense to include it, right? So, but some of you might have included that already. But that's fine. There's not a lot of quotes here. But that's when, for instance, if you're in an interview, you want to ask, oh, does a comma count as a character? If you want me to find the most common, it might happen that this has that many commas that the comma will count as one. So this is something that in that first part of your interview process, asking clarifying questions, you want to ask to make sure you're on the same page with your interviewer. Okay, so let me break this into a few more lines so that we can kind of have everything. Okay, that's all. Okay, so I have this string. Just call it str. I'll change this to let. Okay, so Cam said we could use a object to count how the characters, or to keep track of how many W's we have seen, how many E's we have seen, how many R's we have seen. Somebody else, how would that look like? Using an object to keep track of the characters and their respective count. Let's see. Michael?
Have a row here. We have the individual letters, and I have its own line, its own key, I guess.
Okay.
And then the value of it would be the number of times it's used.
Okay, so it will be something like, let's imagine that this has, I don't know, 10 W's, right? So our object will look something like that. Let's do the object. It will have something like key. The key will be the letter or the character, so it will be W, and the value will be how many characters it has. Something like, let's imagine it has 10. I don't know if it has 10 W's, but let's imagine. Okay, so maybe if I start with this, let's say I'm midway through the string. Let's say I go to the word knowledge and I find this W, I could just increase this 10 to 11 to keep track of the count. Does that make sense? Right. Good point. I don't want to do it manually. I want the computer to do it for me. Another hint that I was giving people for this one is, imagine we have this object with all the letters of the alphabet. Sort of like keeping a count as to, let's see, B. And so we know that the alphabet has 25, 24 letters, 26. Okay, cool. I learned something. So imagine we have something like this, right? And then we look through the string, and we're finding, oh, if you see an E, then go to the E key in the object and increase that by 1. Is that making more sense? Cool. So one way is I could write this object, and if you did that, that's fine. Right? I could just keep going until I get to Z, right? But I don't want to do that. So the cool thing is that the computer can do that for us as well. If it seems like a lot of manual work, there's a lot of repetitive. A computer can do it. If it's a lot of manual work and repetitive, a computer can do it. So I don't want to build this object myself. But what if I go through the string? What if I start with an empty object? I'm going to call this obj2. I start with an empty object. I'm going to put it at the top, so it's before my string. We could have done this route, but I'm going to start with an empty object, and then I'm going to look through my string. And then I'm going to check if my object has, so when we're iterating over a string, we're going from index 0 to the length of the string, right? -1. So the W will be at index 0, right? We all know that now. So I'm going to grab the the W, sorry, and then I'm going to check if that W is a key in my object. What is the answer to that question? Is W at this point in time a key in my object to her object? No. Okay. So I'm going to do check. This is kind of going back to the whiteboarding steps. We want to like list the steps that we're going to follow. So first, I'm going to do check current character to see if it's a key in obj2. Right? Okay, so that's the first thing. Even before that, I should be iterating individual characters. Iterate over the string to get individual characters, then check the current character to see if it's in the object 2. If it's a key in the object 2. The answer is no. So what do we want to do if the answer to that question is no? What do you think? If object 2 doesn't have a key W, what should we do? Peter? Right, add it as a key. So we're gonna check that. If it's not, well, I'm just gonna say if it's not, then create a key in object 2. Create, how could I describe this better? create a key with the current character char. I'm gonna call it current char in object 2. Does that make sense? Okay, so we saw that we're gonna check if the current character is there. If it's not there, then that means we haven't seen one before, right? And as we're starting our loop, W, we haven't seen any other W's. But now let's go on to, our loop is gonna do the same for E. Have we seen any E's before? No, so it's going to create it. So that will be looking like this. I'm gonna write it in a comment because the program is the one that is going to do it. W, I forgot to say, check the current. If it's not, then create the key with the current character in object 2, and set the value to 1. And that by that we're saying, or meaning, we have seen the character. Okay, so not only I want to set the key, but I want to set the value to equal to 1, because we saw 1W. Now we move on to E, we ask the same question, check if the current character is a key in the object. If it is not, so we just add it. So that will be looking like this. 1. Now, if we don't take into account the single quote, in this case, let's just ignore that. The second character after that, we'll move on to R. R doesn't exist in our object, so we create it, and then we set it to 1. Now we moved on to, this was 0, 1, 2, 3. Now we're on I4, right? No, 5. 0, 1, 2, 3, 4. Now we're on string at index 4, which is an E. And we ask the same question, check if the current character to see if it's a key in the object. The answer to that question is yes. Now we have an object with a key E. Then what do we want to do in that case? Increase this count. Now from 1, increase it to 2. Because we have seen 2 E's now. We saw the first E at index 1. We saw the second E at index 3. 0, 1, 2, 3, 4. I'm still minus 1 plus 1. Those are one of the most common errors in programming, an error by 1. Okay. So if we keep going, do we get to see how this will evolve over time? Right, like by the end, right, so on this line, we don't see any other E's. In here, we're gonna see an E, and then our program is going to increment this to 3. It sees another E right next to that, so now it increases it to 4. And so on. And if we do this for all the characters, at the end, we're gonna end up with an object that has the count of all the characters. Okay, here's a question. Would we end up with an object that if we read only the keys, we can reconstruct the string? Would we end up with, so here you can see that here I'm kind of writing the same string, but like vertically, right? And then I guess what I'm trying to say is, if I we know object.keys now, for instance. Object.keys will give us all the keys of an object, right? So if by the end of my program, I pass this object to object.keys, would I be able to see the same string that came in? What are some of the arguments for that, Camille? Mm-hmm. Right, that's a good point, and that connects to what we said yesterday, which objects are not trustworthy for keeping track of order, right? So, any other arguments, Joy? Okay, yeah, that will be. We could reconstruct it in that way. For the purpose of this exercise, that will be a good solution, but we don't need to go that far for this one. Really clever though. Uh-huh. Right. So even though we saw, for instance, let's go back here. We have traveled to VR, right? But in the object we only have 3, right? We're missing one character, which is the other E that we're seeing, right? And then we cannot truly build the string again. Yeah, it will be a clear way will be what Joey mentioned, but I can't think of a way in which we might actually want that, but it's still a clever way. Yeah, Michael.
We make each letter object, and then give it 3 properties. We give it an array of indexes, which are
I think that's sort of what Joey was suggesting, but with an array. But again, we're not gonna go to that with this. That was just a question to kind of check your understanding of when you try to add a key that is already into an object. What happens? Like, can I add another key called E at the end here? Right? Why? Right, because if I say object at key E equal to 100, and then I do again object at key E equal to, let's do something like 100 here, and then 2 here. This is not going to create 2 keys called E. This is going to set a key called E to 2, and then right after that, it's going to overwrite that value of 2, and it's going to put 100 instead. Right? Does that make sense? So that is also a difference to note with arrays. In arrays, you could have, you only have one unique indices, right? You cannot have index 0 and another index 0. There's only one. So that will be kind of the same here. We can only have one key of each. Yeah. Mm-hmm. Right. I think I remembered your approach. And I think your approach was like that because you wanted to account for uppercase W and lowercase W, and you had the counter right. But you had that because you had to account. You had that kind of structure. So what Sharad is saying, instead of he saying W equal 1, he had something where it was like W equal an object, and I think you had uppercase W, lowercase W, and then instead of keeping the count directly under the key, he had another key here called counter, right? Something like that. Yeah, this will be another approach that could still work, and that is something very common where as we learn more, we get to problems that can be solved in very different ways, in many different ways. Any questions here? And I wanted to show you how this is actually going to happen. Yeah, Michael.
Well, I guess we wanted to reconstruction. Are you find that you should establish the keys first?
I'm not sure what you mean by that. But
when we take the string, turn it into an array, and when building our object, we put the value there.
I think we'll need to talk later. Yeah, I'm not sure as to what you mean. But what the point that I wanted to demonstrate here is the fact that if you're in an object, you're not going to have repeated keys. Keys are unique, and therefore they value that the whole. So okay, so we check if it's not. So if it's not, then we do. Let's do. This will be kind of like pseudocode, right? So here I'm kind of writing an if statement, but I'm still speaking in plain English. If it's not, then create a key and then set the value to 1. Here, otherwise, kind of the else. Else, what do I want to do? What did we say that we wanted to do? If it's already if it's already a key in the object, then just increase the value. Of increase the value that the key character is holding. Does this language make sense? If it's not, check if the current character is in the object. If it's not, then create a key. Otherwise, increase the value that the character we're looking at is holding. That makes sense? Thumbs up if you think that makes sense. This phrase, increase the value that the key character is holding. This, to be more precise, current character. Okay, so let's see. Ken, what you did is something that we described here. It's basically what we described here. Okay, so let's look at Cameron's solution. How do you? Is it okay? Okay. So let's see. Oh, so you have an array with all the alphabet. I see. Let's see before we copy it. My string letters, highest num for value of letters. Okay. Oh, and you're doing some regexes as well. Wait, these are two different solutions? Oh, okay. Okay. I think we could talk about some of the stuff that you're doing here that is not truly necessary. For instance, the regexes. What is else? The fact that you have this other array, we could have done without them. Still, if it works, it's like, well, let's try it. I think it works. I'll need to do this. So we have the string letters. Let's write node is review. So Cameron will end up with an object that looks like this, right? This is what I was describing earlier, where we have we have all the keys or letters of the alphabet, and we have the count. Only the ones that show up in the string. Okay. Okay, cool, absolutely. We don't have a Z, but almost all of them, right? And then it says the most common letter is E with a count of 25. Those that answer this question, did you all get 25? Oh, the 19, right? Oh, you got O? Yeah, Peter? T? I think, Mike, which one do you have? You had T too, I think. The second most common letter? Okay, so do you have O? Okay. Anybody else got something different? Janesh? A little bit louder, I cannot hear you really. It seems like well, according to this count, you will be O, 19, right? Okay, so we, as I said, we basically only need this part. So let's try to write a version that is a little bit less code and with a, not that that's better, but a little bit that is a mix that is a little bit more concise, and we're not doing repeating ourselves or doing anything extra. Okay, so the first thing that I said, thank you, Cameron, nonetheless. Mm-hmm. So I said we need to. Oh well, this is only solving part of the problem, right? This is only building up this object. The second part of the problem would be once we have that object made, we have to find the most common letter or the letter that has. First, we want to find the most common letter. After we found that, we can find the second most common letter. Peter? It's O? Okay, cool. I see. Okay. You see, this is the importance of peer reviewing. This is why peer reviewing is a thing, in not only in the scientific world, but in code. Char? Yeah, we're gonna get to that. Mm-hmm. So, yeah. Okay, so let's get, so the second part will be, let's do this part first, and then after that we describe the second one. Okay, so we need to, as I said here, iterate over the string to get individual characters. So let's do that. How do we iterate over the string? I see some of you, I wanted to address this. Some of you converted the string to an array with that split, right? That step is not necessary. You have some of you, I saw some of you have something like rstr, which is str dot split, like that. This will just turn the string into an array, where every character is an element in the array. But because string is already array-like, where we have indices that we could access individual characters, we didn't need to perform this step. Okay, so don't do this if you are looping through a string because you don't need it. Okay, so now how can we loop through a string to visit every character individually? Do this.
Line 0. Line estimate. My string.
Right, I call this string str. I++, right? this one should be pretty familiar to us by now. The good old loop, for loop. What's another for loop that we could have used? Maybe more less known. The for element or car in str. Right, this is saying for every car in the string. Is it a for off? Let's find out real quick. Node a equal 1, 2, 3 for that element off. I think you're right. I think it's off instead of the in. In is for objects. But let's see. Actually, I think this should work in this one, but we will see something fun. In A, console.log element. So here, we could use a for in an array. The same way we could use a for in an object. But what does for in an object loops over? The keys, right? So if you do, we saw that yesterday where we had the object winter, the object closet, and we have the 2 keys, right? And then we use a for key in object. In this case, because indices are sort of like keys, we have 0, 1, and 3, right? We get the indices of the array. But that's not really what we want to. We want to have the elements themselves. So we could do this loop for off. And then if I run this, I actually get the elements that are inside. Okay, so we could have done a for off, but we're gonna stick with the good old for loop for now. Okay, so if I want to console log every character, I could just do console.log str at index I, right? Because I is going to be moving from 0 to the length of the string -1. I should see all the characters logged to the screen. So let's do that. Let's see it. Node object review, and what we end up with is a vertically printed version of our string. We are defrauding people with information, right? Does this make sense? Right, because we're console logging every single character. And in console log, for every console log, JavaScript adds a new line, right? And then that's why it ends up being printed in separate lines. Okay, but I don't want to console log each character. So I'm going to what I said here, which is check if the current character to see if it's in the key, if it's a key in object. So let's take our object here. Should let me comment this. No, let's just take it. I'm gonna lower it so that we can see it. I can just do this. We start with an empty object. Okay, we're gonna deal with just object, yeah. I like to, instead of keeping myself to say a string at index I, what I like to do is I create a variable called current character or current anything, and then I just say, okay, that current character just be equal to the string at index I. Okay, so here if if I console a current character here, I should still see the same thing, which is printed vertically in here. Any questions up until this point? Okay. So the second thing I said here is check if the current character to see if it's a key in the object. How can I check if anything is a key inside an object? How could I check if a specific key is if an object has a specific key? Joey? Right. We could take advantage of the fact that if the key is not in the object, when we try to access it, it's going to give us undefined. For instance, if I do console.log object.alejo, that's a key that doesn't exist in the object. In my terminal, I should see undefined. Undefined, right? Let me comment out the rest of this stuff. So we can take advantage of that fact, and then we can use an if statement to see, okay, if we try to access the key and the value is undefined, then we know that it doesn't exist. So how could I write that if statement? Michael? Not equal? Okay. If it's, but is this correct? Right. So what I'm missing here is I want to check if that current character is a key in the object. So I need to say object at dot key. If I say current character equal undefined, I'm just checking if in the first iteration if W is equal to undefined, right? If I leave it like as it is, I'm asking if W is not equal to undefined. But that's not the question that we want to ask. The question that we want to ask is check if W is a key that exists inside our object. So what we do is we try to key into that. We try to key into that property of our object by saying object at current character. Object at the current character key. Is it undefined? So if it's undefined, it means that it doesn't exist, right? Malik? Would it work if I use object dot? You mean the other notation, the dot notation, right? This wouldn't work. Who can explain why? Michael?
Because the trying to access that column function, whereas we can, unlike an array,
Or the square brackets?
you can use the square bracket.
Not quite, but this is what we're doing here is if we do with this dot notation is we're asking if this object has literally a key call, right? We're asking if this object has literally a call current char. But that's not what we're interested in. We're interested in the value that current char holds, which is going to be one of the characters in the string, right? So if we're interested in that value, then we need to use the square brackets notation to say, okay, first can I read what the value of current character is? In the first iteration, it will be W, and then take that W and go check inside the object. Is that a little more clear, Molly? Oh, Joanne? doesn't represent the index. It was going to hold the string at that index, the character of the string that is at index I. It's going to hold either, as this loop iterates, current character will hold W. After it holds W, it's going to hold E, and so on and so forth. Okay, so we check if it's undefined, meaning it doesn't exist in the object. And then if it doesn't exist, what did we say that we want to do? Create a key in the current object, with the current car in object 2. In this case, just object. So how do we create a key in an object? Just keying in, right? So if I could do object current char, and then I need to give it a value. What value am I going to give it? I, in this case, will be 0 in the first iteration. So value 1, why? A little bit louder. Whoever was in that table, I couldn't. Yeah. Right, because when we find that a key was not there, that means we saw that key or that character for the first time, and we want to start the count at 1. We found 1. Okay, so that's if it doesn't exist. So okay, let's check what we have working here. This is also something that you want to do a lot, which is checking on every step. Douglas?
Super fast. Why can't you do objects brackets per character ++ instead of
Good. Here,
right?
instead of that, I could just do. You want something like this: current character ++.
Because it's undefined to start. You need to first define it.
That's correct.
Okay.
So it's undefined. So it's as if you were saying undefined ++.
Right.
Let me know what that gives you. So we want to start at 1, but we want to do ++ in the next step. So okay, before we move on to that, I wanted to console log object, see what we have. Node objects review. Look at what we end up with. This object, we're floating GPWTHMA, period, new line. Does this make sense? Okay, it doesn't make sense. This whole line. Right. Why is it only logging 1E? Michael?
Because when it loops back, so for example, loop 1, we established W, 2, we established E, 3 slash. Then when it gets to the fourth index of the then when it gets to the second, since it doesn't meet the condition, object since it's not defined, it's not gonna.
Right, and then this is something that we're gonna have to learn how to utilize, but I want to see if I could get it set up to show you kind of how this is working. Let's do. This is not necessary. we're gonna learn how to use something called the debugger. And the debugger, well, it helps us find bugs. That's the whole purpose. But the debugger can also provide a really good insight as to how our program works. So here, I hope to demonstrate how if we could slow down the for loop a little bit, in which we could control it when it goes to the next loop and check what object is at every step, that'll be great because that'll clarify some of the assumptions that we're currently making and maybe some doubts that we might have. Oh, so I have to open the folder. So let's hit this, go here, and then review, debugger. I'm gonna add that, save this. Right, so now what I can do is I can place these red dots anywhere in my code, and when I place one of those, I know that this is also possible in Atom. I'm not that familiar with Atom, but it is also possible. If not, you can just switch to VS Code. Prettier is actually a formatter. It will just rearrange your code to make it prettier, but it doesn't do this yet. But there are others that will do that. But okay, so I'm just putting this here, and now I can hit this thing here, and now, oh, actually, I'll need to add some zoom. Let me just settings, font size. Okay. Not sure if this is fully going to work. Let's see. So we have our for loop, have the red dot. I'm gonna click play, and then now my code is stopped here. And I say when it continues and what it does next, but it hasn't gone into the loop. It's like frozen in this time in place. So we can see that at this point in time, I is undefined. Let's see when I hit this next arrow. Now I is 0. So that means that we ran this first part. Now we are running this second part, or we're actually computing the length first. Right after that, we have current character. Now we are inside the loop. You see this yellow line? We're inside the loop now. We can see that current character is undefined. After I press that, current character now is W. Right? Does this make sense though? Like we are at the current at this point in time, we have I equals 0. Let's see if I could lower this thing. I'm sure if I could. Seems like I cannot lower that. But let's see. We have, in this left side, we have all the variables that our code has. On the little what? Oh, cool. Thank you. Yeah. Okay. So we have here, we are inside the for loop. We are stopping the if statement. We have these other blocks. We're gonna get to, or I guess hopefully this kind of makes sense that because we're in the for loop, we are inside these square brackets, right? The curly brackets for the for loop. That is to say, we are inside of the block of code of the for loop, or the body of the for loop, and that is this one here. So that's a piece of code, and then in there we have I equals 0, and then we have this other block, which is this other one in here, and in here we can see the value of current character. So now, because I'm controlling what goes on in my program and at the speed that it's going to go, I also want to see my current object, what my object looks like. We have this one, object, just object. It's an empty object for now, right? So, okay, and we have our string, and that all makes sense. We can ignore everything else. But now let's see. I'm gonna hit next. That seems that it went inside the body of my if statement. That means this condition was true, right? Because we're now, the blue line is, the yellow line is line 75. Inside the if statement, that means the if statement gave us true. Here I can also hover over variables and see what they currently are. So here I hover over current character, and it's equal to W, and I can hover over object, and I can see that it's just an empty object. Okay, let's keep going. Oh, we jump back to the for loop, right? This is what we expect in a for loop. The for loop will run the statements that are within the body of the for loop, and then jump right back up. So, but let's inspect our object. Let's see. If I find it here, now I have this, an object with a key W, and it has the 1 inside, right? This was the result of the first iteration and the if statement that added 1 under the W, the current character. So again, if I hover over here, now I can see my W here as well. Then I can just keep going. Now current character is E. Now that's the second character in the string. We see that we ran into line 75 because, well, this statement is true. After that, we go right back up. Now if we inspect what object is, now we have an object with 2 keys, W and E. Let's go on to the next one. What is current character now? Seems that it's another E. Wait, did I jump over one step? No. That's it. Now current character. Oh yeah, I was still in this line. Now current character is the single quote. Depending on your case, you want to ignore these special characters like quotes, and you don't want to count those towards the most common letter, for instance. In this case, we're just ignoring them. So even that single quote is going to be added as a key in our object. So right after I finish this here, I can inspect my object again. Now I see that it has a key single quote and the value of 1, a key E and the value of 1, a key W and the value of 1. Those are the 3 first characters we have seen, W, E, and 1. Does this make sense? Okay, so let's keep going. Now current character is R. So after that, I check my object again. Now I have the 3 previous characters, colon, E, W, and now we have R equal to 1, right? Because we saw that. And we can see here I is equal to 3, right? So the character at index 3 is R. Okay, after we do one more time, let's see, this is an interesting case. Let's see what current character is going to be equal to after we run this line. We run that line, and current character now is E, right? That is at index 4. If we go here, that matches this one, right? Now here with this line 74, we're asking, is that character a key in the object? What's the answer to that question if we inspect object? Yes, right? So, well, in this we're asking kind of the opposite. Is that character not a key in the object, or is it undefined, which is to say it doesn't exist yet? We are going to, I'm going to hit next, and then you saw that it just went back to the 4. It didn't go inside the if statement because, well, the condition was false. This condition was false. If it's not true, it never goes in here. Yeah. Define? What do you mean by? Right, exactly. It is. Yeah, it is defined, or it's not undefined. Okay, so now we have that, and let's look at our object. Our object didn't change at all. We saw a second E, but it didn't change, right? Instead, when we see a second E, what do we want to do again? Increase the count, right? So if we saw a second E, this E here should now be equal to 1. Sorry, 2. Okay, so if we're doing that, we could do, okay, if it's not, so I'm going to stop this for now. If it is defined, or if we already have a key with that that matches that character in an object, then we do the else, right? The opposite of this, meaning it is defined, it is already a key. We do what Douglas suggested earlier, which is current car ++. Because now we have set it to, before, when we're seeing the character for the first time, the character doesn't exist in the object. We initialize that to 1. Once we know that it is in the object, we go into the else and we just need to increase that count. Does this make sense so far? I see a very few no's. That means it doesn't make sense. Let's see. Both? Oh, okay. Let's see. Who can describe? Let's see. Let me pick somebody at random. I had to write that program yet. That's what I wanted to do with all your objects and all your names and put them in an array. So I could write a program that I could run and it will give me a random person, one of you, that I could ask questions. I'm still gonna do it at some point, and you should be able to read the code and it should make sense. Let's see. Maybe Siham. What are we doing here? Tell me with your own words. This for loop. Describe what we're doing. That's correct.
Then after that, we're going to look character. Let's take the first. We define like the first character.
Right, we define this variable?
Yeah, the first one.
Okay, in the first iteration is going to be the first one, yes.
Yeah. Then we're going to run the addition. So basically, if the first character is undefined.
Okay.
So we're going to put the number one. So basically, the first character is going to show up.
There is one thing there before we move on is it's not as if the character is undefined.
Basically, it show up the first one. The bit is undefined. So when it show up, then we have to put them on it.
That's correct.
And then we have to go over the whole tree. We see the second one show up the same letter, show up the second time.
That's correct. Yes, it was just that in the language you said if the current character is undefined, but in this case, we're like a way in which you could have said that is the object at the key current character is undefined. Yeah, Pearl.
So essentially, undefined
if it's undefined, is if it's not in the object. Okay, so if we do that now, when let's run it again with this. Let's see what object is. Objects, we started an empty object. Now I'm gonna go a little bit fast over this, which is, now the loop is going on. Now we have object, we have E and W. We're gonna keep going. Now we have in the object ERW and the column quote. Now let's see once we see the second E. Right? So now we are in the second E at index 4. the second E at index 4. We're asking this question: is object at key E undefined? It's not, right? Because it was already there. So in here, once I hit next, we should see the yellow line jump to the else statement. We see it jump into the else statement because this is not true. The else statement is going to say, okay, object at that key, at the current character key, increase that by 1. Then if we check our object now, we have E2. And then if I'm gonna see if I can put another one here. Now I'm gonna let it go straight. Now, the loop ran completely. Now it stopped before it console logs. So, and I did that because I want to inspect what my loop looks like, or what my object looks like now. And I end up with this object that I could have console log as well. So this object is the total count of the characters that we found in the string. There are 7 A's, 1 capital A, 3 C's, so on and so forth. What is the problem with this that we think, or that we might not want? Cameron? It's not case insensitive, or it's case sensitive. Yeah, that will be the same thing. Right? That's something that if you're in an interview, that's a question that you would ask. Do you want it to be case insensitive? Because for the interview or for a particular problem, capital A might totally be different from lowercase a, right? But yeah, see how? A period?
Yeah.
Let's see. Let me get out of here. Let me just run this regularly the way that we have been running it with Node. This. Do you see something like that? Yeah. Okay, and then you said this period 4? Right. So this is saying, again, this is what this is something that you will discuss with the interviewer or the problem. If this is a coding challenge that you're doing, or an online coding challenge, sometimes you can make assumptions. You can say, okay, the I is not really a character. The dot is not really a character or it is. That's all subjective, basically. There's no right or wrong in that case. The right will be always ask, right? Yeah. Mm-hmm. Sometimes there's not a set rule. Sometimes it's just one-on-one, you with one engineer. Sometimes it's a pair and you. Sometimes it might be an entire team of 5 and you.
But not you, somebody else.
Oh, right. No, it's always you by yourself. Mm-hmm. Okay, so once we have this count, now we can answer the question, which is, actually, but wait, let's say, what would be a way in which we could make this case insensitive? So that let's say the interviewer says, for me it's the same, capital W is the same as lowercase w, I want them to count. Yeah. Sandra? Change the string to lowercase, or in other words, just lowercase the entire string. So I could do that if I do str is equal to str, but now to lowercase. Right now I lowercase the string. So if I run this now, we now see 7 W's. Before we had 3 capital W's and 4 lowercase w's. Now because we made it we lowercase the string, everything is lowercase now. So both a capital W will now count as a lowercase w. Yes, yeah. What do you mean single quotes? Wait, you mean in, oh.
So basically,
Wait, you mean that this string has this single quotes? Is that what you're talking about?
yeah, because I see there's
You're seeing a single quote 32 somewhere here. This? Oh, this.
Yeah.
Okay. This is another good point, which is there are 32 spaces, depending as to whether you count a space as a character or not. But then how can we get rid of that? Yep. Okay, a condition that ignores spaces. I could do that if I... Okay. So I only have this condition if it's undefined or otherwise. So, but that's right. I could only do this if current character is not equal to a space. And then that if statement will wrap the others. Because that's the first question that I want to ask. Right? And then if I want to ignore periods too, I can say or current character is not period, and so on and so forth. Something else that I could do is I could have another for loop that just gets rid of everything that I don't care about, and it leaves only the stuff that I care about. But this is totally fine. So let's run this again. Oh, it seems like we still have something here. Wait, did I save? If current character is not that, or is not in a period. For some reason, it's still running the period. Right, that's a good catch. But then the and will never run, because a character cannot be two things at the same time. So
No, you're saying it's not. You did the concept.
here's something I could do. I'm going to close this if statement here. Now I'm going to ask two questions. One is, if it's not one of these characters, then one of the words that we saw very briefly is, I bet most of you forgot, continue. Wait, one at a time, Michael? With the end?
Yeah, I have the same thing with the end.
But the thing is,
you say not. You said equal to, but I say not equal to. Like for example, if it's an E, it's not equal to both. Both conditions true.
with just and?
Yeah, because it's not equal to space and it's not equal to period. So if it was like A, it's not equal to either of those.
So current character, I see, yeah. So then I could just add all the others that I don't want, that I want to ignore in the end, right? I will just keep going, adding. Let's say I want to add or ignore current character is not equal to the new line, right? In case that we want to ignore that. So because it's not equal to, let's decompose what this is not. I see. Right, then maybe that will make more sense if we do this. No, if it's character equal to.
If it's equal to at least one of them, the whole state. You have to do all of them equal present order.
Now I'm getting confused.
So if you had 4 here, right? And you had this equal and sequence, at least one of them has to be true.
Oh, for the or to, right? But if one of these is true, then it's going to go inside the loop. So I guess let's try it.
Oh yeah.
If at least one of these conditions matches, then it's going to go into the loop, or not into the loop, into the other if statement, and we don't want that.
I mean, can you put a not?
We tried that, and then it happened, and then you told me why it didn't work.
No, it worked there.
Oh, look now. Just to explore the other options. So this is counting. Let's say this could be a version of the problem. I'm only interested in this subset. I'm only interested in how many spaces there are, how many new lines there are, how many periods there are. But then just to stay on one, we'll have if it's not equal to this, and is not equal to that, and is not equal to the new line, then run the rest of the code. Yeah, Cameron?
But what if you don't know what the equal characters are?
Uh-huh.
Let's say that you have an entire book. Have additional types of characters.
Uh-huh.
And write the entire book worth of symbols and codes.
Yeah, that's a good point. That's a good point. I'll take that.
So like, is there a way to kind of like sort of
Again, that'll be all very subjective. Like it depends on the situation, on what the details of the question is asking. If you have an interviewer or a person who you can ask to, but
always ask the question?
I guess like in your case, it's good that you're thinking in a defensive way, which is let's account for only characters of the English alphabet, right? Okay. How do we feel about this then now? A little bit better? Cool. Okay, so because we know that this is another character, let's just ignore this as well. What I'm going to do for that is I'm going to just separate this here. If current character is not backslash quote, now we're only with the characters that we're interested in, right? got rid of all the others through this if step. Oh, but I think there might be a bug here. I feel like, well, this condition still feels kind of weird. It doesn't feel very natural. But we're gonna run with this for now. So we can move on. Oh wow. We're only gonna get to see an introduction to functions in an hour, the hour that we have left. Wait, no. It's almost 4. 2 hours, okay. So we have this object. We have all the characters from the string. Now how can we find the second most common character? First, let's see what would be the second most common character. Let's find the most common character will be E. So the second most common character will be O, right? And the third most common character will be T. So we did that. Now we have our object. Again, this also demonstrates another principle of programming, which is you want to do stuff. You may have your code do a piece of it first, or shape the data in a way that makes sense to the problem that helps you, and then have another piece of code that does something else. So that's what we did here. The initial for loop, the only thing that it does is it creates this object. Then after we have done that, we can write another piece of code that helps us find the second most common character, or the most common character, or whatever, or what will be? Oh, there's only one queue. It will be fun to know where that one is. But yeah, you have a question now. Okay, so now how can we find? Let's find first the most common character. We as humans, we know it. If we look at them, we just scan them and we see that E has 25. We found 25. But I want the computer to do that for me. Any ideas? Let's find the most common character first. How could we get that information out of this object? Yeah.
I created an array of value. Use the code to find the largest value. And I think it's good index. Bring it exactly how we do it.
The index, okay.
Index. Using the index, I found better.
So the approach that Mike is saying is he remembered that for arrays there was one problem in the lab, which was find the second largest number, I think.
Oh, I think it was smallest, but I just changed.
Right. So that is a very similar problem, right? If we have an array and we want to find the second largest or the second smallest number, what we want to do is we want to go over the entire array, checking, and we start a counter, or we say, let's say, in this case, W is the most common character. I'm just assuming that, right? Because I haven't seen any others. But now the next character that I see is E, and that has 25. So 25 beats 7. That means that then E has more than W. So I may want to keep track of now E instead of the W. And I'm going to compare that to the next character, which is R now. And R has 11. Is 11 greater than 25? No. So we keep going until we try to find something that is larger than the largest thing we have seen so far. Okay, so for doing that, something we could steps that we can follow is we know that we need to look at every single one, right? So how do we loop over? If we want to look at every single one, a loop makes sense for that in arrays, in objects, in strings. So let's do a for let key in object, this will be a for loop, a for in that allows us to look through the keys of an object. And then for now, what if I just do console.log key? What am I going to see in the screen? Oh, yeah, I guess. Let me comment this one, save. Now we have only the keys, right? But rather than just printing that, and this is kind of what I wanted to get at in the question that I asked earlier, which is, if we build this object of all the characters, could we rebuild the string? Right, in this case, we only see that entire string is not even using the entire alphabet, right? So we cannot really rebuild it only from the keys. Okay, so we don't want to console log the key. What we want is we want to try to find the most common character, right? So for that, it will be handy if I have a variable. Let's call it most common. I'm going to let that maybe as undefined. And I'm also going to do another one, most common count. This will probably start at 0, right? If you haven't seen 1, we don't know exactly. I could either leave this as undefined because we haven't seen 1 yet, or I could initialize it at 0 because that's a fair assumption that if it has at least 1 character, it was going to be different than 0. So 0 is a good number to start, but let's don't do that. The next thing that I'm going to say is, I could say something like this: if the object at the current key, right, or the value, this is the same. I always will repeat myself saying the same thing in different ways so that try to see which way makes more sense to you. So I could say this is the object at the key, or the object at the property key, or I could also say if the value that is stored under the key called key in object is greater than the most common count, then that must mean that we saw a character that had a greater character count than the thing we saw before. In this case, I would say most common count will be equal to the object that key. And I also want to keep track of most count. So, or most common. Most common, I'm going to say that is equal to the key. Yeah, I could here, whatever makes more sense to you. You could call this key, and I think a name that will make more sense is if I call it char, like for character. Right, for character in object. So here I'm saying, is the character count at this character in object greater than the most common count? Right, but the thing is, I cannot say, is this greater than undefined? Because most common character is undefined, right, currently. So if I try to, let's try to console log here, most common, and let's try to console log the most common count. Let's see what we have. Undefined, undefined. Does this make sense? The fact that, well, the fact that most common and most common count is undefined, right? Because we're never running into this if statement. Our code is never going inside this if statement because, well, most common count. It's like saying this object in the first iteration, this loop in the first iteration is saying is 7 greater than most common count. So we'll be doing something like 7 greater than most common count is undefined, false. Nothing will ever be greater than undefined. That will be a philosophical question. What about NaN? I think it will still be always false. But just to keep us in point, so that's why I said it will be reasonable to start at 0 here, so that it's not undefined and we can actually start getting somewhere. Say that again? It is reasonable to start at 0 here, right? So now let's run it again. Now we got our most common character, right? We have E and we have 25, right? Because, let's see real quick with our debugging tool. I'm going to ask my program to stop at this for loop, and then I'm going to run it. So it's there. You can see that most common count is 0, most common count is undefined, character is undefined, so let's go into the for loop. Now character is W. That makes sense because W is the first key in our object. Now we're asking this question, is object at W greater than most common count? What's the object at W? Object at W will be, at key W, will be, I think, 2, 7, right? So it's 7 greater than most count. That's true. So let's see what happens. We go inside the if statement. We set most common count to be equal to 7, right, to the count of the W. After that, we also want to keep track of which character that was. So we store the character in something called the most common. So now most common here is W. And the most common count was 7 because, well, we started with 0. Now we saw W. W has 7 characters. That's greater than 0. It makes sense that we keep track of that W. But only momentarily because let's see in the next iteration. Now character is E. And now it's asking object at key E. Is it holding a value greater than most common count? Object at key E. Let's see what object at key E is. I think we cannot fully see it here, but in the terminal we saw that object at key E is holding the value 25. So in other words, we're saying it's 25 greater than most common count. Most common count currently is 7 because the last thing that we saw was W and it had 7 in it. So now here we're saying 25 greater than most common count 7. True. Now let's go in. Now let's update most common count. Most common count now be the new thing, which is 25. And then now the most common character, instead of being W, be E. Because, well, the count of E beats the count of W. Does this make sense so far? So if we keep going, now character is R, and it's going to keep doing the same thing. It's going to ask, okay, how many R's do we have? We have 11 R's. What's the most common count? The most common count was 25 of the E. Is that true? 11 greater than 25? No. So we never run inside the if statement ever again because, well, we saw the E, and the E character count was 25, and nothing else has a greater count than the character E in our object, right? We can tell by looking at this. Okay, so any questions to this point? Yep. Oh yeah. Okay. You all have this code so far? Okay, now find the second most common character. Take 5 minutes to try to, using this code, you have to modify a little bit to now keep track of the second most common character. If we were able to do the most common character, we were able to do the second most common character. I'm gonna take 5 minutes to grab water and charge my computer.
I get it, but I don't know.
Oh, thank you.
I was saying about the dot function, how it's pretty easy to use the dot function to what do you call it? Create the object.
Uh-huh.
So this is wrong. Um, so what I did here is so dot match gives you the array of the occurrences. I did the length of that, and that gives me the I'm keying in.
I see. To that character. The problem with that is that you're in math, so you probably understand these languages. Is the time that runs for your program to run is quadratic. So mine is linear, or the original before. Because in case we're gonna get to talk about
I
this.
was thinking about that because I saw that this is like it's inefficient because
That's another for that's checking.
yeah, every time the letter occurs, it gives a match.
Uh-huh.
So I wanted to know if there's any way I could take out the loop and just have different.
But I don't know. That will be more research on the regex part. I don't think so.
Because I know there has to be a way where I could just negate the loop. I won't use the loop.
But yeah, that will be quadratic. We have two loops, but the two loops are out of each other. If it was nested, a loop inside a loop. So this is a loop, and then this is another loop to match internally. So this will be quadratic because of that. But in the solution, the original solution that we were demonstrating here, we only have one.
Efficient. I saw that.
Uh-huh. We rarely want quadratic time is pretty bad. We very rarely want that. Cool. Okay. Let's keep going.
Trying to get it up.
You will need at least one loop. That's the one that we're writing. Because you need to look at all of them. I think because this is linear time, Unless the string was sorted, there is no way to get it faster.
What if I do an array? I create the array, set that equal to dot match. Like, so create an array, make this an array. Then right here, where I'm declaring the
I'll say try and then probably show. Okay, so the best to get that second most common character. Let's see that here really quick before we get into functions. So, from the people who were trying, who managed to get it in that time? I think, yeah, Douglas.
Another set of variables.
Okay.
Second most, and second most count equals 0.
Second most. So Douglas suggested we create another set of variables to keep track of the second most. I'll say that makes sense. Uh-huh.
So you're collecting it from most common count.
Uh-huh.
If else, then
We won't need any additional if, I think. Who can help Douglas? Douglas came with the idea of let's create another set of variables for keeping track of the second most common. So you. Okay. Same loop. Okay. Okay. And what would that condition check for? That's the most common. Okay, so it will be else if. So we could get it without this condition, but first let's see it. Uh-huh. Oh, you have it here? Wait, so you have an and here that says if the, so this will start at 0 as well. And you have if, let's just so that we don't use that much space, I'm gonna put it here. If object character is less than second less than the most common character. Wait, not the count here? Right, okay, so that in that case will be 0 in the first round. That will be this one? But in here we're comparing two things that don't make sense, which is this object, a character, will be the value, right? So for t, it will be 17. And then we're comparing, is that less than the character, which will be the letter t? Here? Oh, here? Right, actually, before we go into that, let's see if this one makes more sense. set most common equal to the previous most common. Just char. Erase this one. Okay. Do we think this will work as it is? What does or somebody else think? Let's try. Maybe. So let's print the most common, followed by the second most common, separated by a line of this. Okay, so we have most common is undefined, most common count is 0, second most common undefined, second most common count 0. So let's see if this makes sense. Let's get rid of this. Let's put that back here. We're gonna have, let's get back to this, what we had before. This will find the most common. Or in a separate loop, but I say we can do it in one loop. So let's do that. So we found the most common character, right? We did that with this set of variables. Now what we need to do is the second most common character, in this case, wait, actually, maybe my approach will not work. I was thinking we could loop, keeping the second most common character as if it was our most common character, but then that wouldn't make sense. Yeah, Cam. But actually, before, let me try something before we do that. Let's see, I'm gonna treat second most common character as my most common character. So I'm gonna say here, second most common character. Most common character. And then here I'm gonna say sec. Right, so right now, we know that this is not the, wait, why am I saying 1? Oh. Got it. Sec most common count and car. This one has to be that, and this has to be, no, count. And this one the character. So what's going on here? Second most common count. And the if statement, right? This one is still looking for the most common. So let's have this search for the second most common character. Right, okay, we have, so far we just switched the name of the variables. What we want now is, we could say, okay, we're gonna keep one variable holding the previous value before we remove the next one. So what do I mean by that? I mean, when we update the second most common character, we are also going to say the most common character is going to be equal to whatever it was before, or the second most common character. And then the second most common count is going to be, no, not this one, but the most common count. Let's see if this makes more sense like this. Most common count. Oh, but in this case, we're not going to get the same. I have to do this first. Before I overwrite it, like this. Let's run this. Let's see what we have. We still have E. So what I'm trying to do here is, could I use a variable to keep track of whenever I'm finding a new most common character? Keep track of what was the last thing before. What was the most common character before? In this case, it will be W. Oh, but then I see. In this case, W will be the first most common character that we see, right? So the way our program was initially written, it will override the most common character once it sees that E has a greater count, right? E has a greater count, so now most common character will be equal to E, right? And then I lost the W. So what I wanted to do was try to see if I can keep track of the W that I removed earlier. But then, does that seem to help? Right, Joanne is saying that doesn't seem to help. And she's right. Because, well, once we see E, there is no other character that will ever beat E, right? Because E is the most common character. Okay, so we tried an approach that I thought was going to help, but it didn't. Now let's keep trying the, Cam, you had an approach where it was with an else if here.
Yes, because you can't keep the model.
Okay, so wait, let's get back to the most common character will be equal to object character, and then, no. This will be just the character, and this will be equal to the object at that character. Okay, we're in this page.
Yeah, so the statement one where basically targeted with the section.
Okay, so
that's lower than highest.
So now you're going to do if it's not greater than that, just check if it's a little bit lower than the most common character, right? So we do object at character. Is it lower than the second most common count? Wait, this will be most common count here, and then this will be most common count here too, right? So say that again. In here,
You want it to be the second. So you want to compare the variable.
If it's lower,
You don't want to use the variable R. You're just comparing the highest and the second.
so in this and in here in the if statement, what do I write?
Second most.
Is the second most common?
Common count less than most common. And now you're certain that this number is going to be less than times now.
Okay.
So
And
second most common has to be less than the value.
Is less than the object like character.
It looks weird, but once you start adding the numbers into the second circle, it'll make sense.
Let's see. And then here you just say second most common character, or the count will be equal to the object. And then the second most common card will be equal to just char. Okay, so here we're saying we were just keeping track of the most common character the way that we were, right? Just in that case will be E. And then once a character is not greater, or it doesn't have a count that is greater than the most common count, is going to fall into this else if statement. And then it's going to do this other comparison. Is this current second most common count less than the most common count that we have so far? Let's see, that's that. Second most common count will start at 0. Is 0 less than the most common count? In that case, it will be true, imagining that we are currently in W. And then we check and then we have the end of that if statement. And second most common count, which is 0, is less than the current count of the, or is less than the count of the current character. In this case, that will also give us true because the second most common character is 0. And then object at character will be 7 in the first iteration. So I'm getting a little bit confused here. Let's try to run this. Let's see. 19. So this gives us the right answer, but I don't quite understand why yet. So what can I do? Right. I could use the debugger, I could use console log to see maybe, let's try to use a console log here. Let's see how many times do we get in here into this if statement. This console log most common. Or actually, let's do a string interpolation. So let's do the most common followed by the count. And let's also see second most common. So I'm gonna just do that here. Put this bar to separate them. And I'm going to say, I'm gonna just copy this. I'm gonna paste this at the end. And I'm gonna replace this with sec most. So that I see at every time what most common character is and what the count is. And I also see what the second most common character is and what the count of that is. Let's try to run this. And it seems that we only have it twice. Am I right? So we see the most common character makes sense, right? That's E with a count of 25. Let's see, the most common count, the first, right, that is 25, and then the second most common character, the first time around is undefined, right, because that's how we start second most common character here, as undefined. and the second most common character initially is just 0. That's what we see, the 0 here. And then so that means that we went in there. Let's do one more here, so that we have, this will be like the after the body of the if statement, right? Let's see that. So we have this. Let's see if I can have like that. The first time that we went inside the if statement is when we have the most common character be E, and the value of that being 25. The second most common character is undefined. Well, that's because we started with undefined here. And the value of that, or the count of that, is 0. That's again here. But after that, we do, okay, we print again the most common character after the body of the if statement, which were these 2 lines, right? This is truly what is doing the work. These 2 lines will modify the second most common character, right? So after that, we console log what the new second most common character is with this arrow, so that we can identify, tell it apart. And then we see that the most common character is still E25, but now we define a second most common character, which was R. Let's see why we did that. So we start at W with 7, right? Is 7 greater than the most common character so far, or is the count of W, which is 7, greater than the most common character so far? The most common character so far, the count of the most common character so far starts at 0, so it is greater than 0. So that means that we're going to have the most common character be 7 in the first iteration, right? So that means that we fell into this if statement, because indeed 7, again, the first time around, 7 is greater than the most common count. Most common count starts at 0. And then we say, okay, most common character, now just set the current character, which will be W. So let's actually, I think it might be more helpful if we run it here. Let's stop it here. Let's run this. Let's see it all happen. So again, these are undefined, 0 and 0. We step in. Now the first character that we see in the object is W. Now we're asking, is the object a character W has a value greater than the most common count so far? That is to say, 7 greater than 0. That's true. Now we say, okay, set the most common character to the current character, which is W, and set the most common count to the count of that character, which is, in this case, 7. So now currently we have most common character we have seen so far is W with a count of 7. Now, we went into the if statement. We never ran the else if statement. We go one more time. We ask the same question. Object at character E, or at key E, does it have a value greater than the most common count so far? Right, that's 25, greater than 7, true. We go in, now we set most common character, we set it to E, right, the new most common character, and the most common count, we set it to 25, right, the count of E. So we can just keep doing that. Oh, we ran into the else. Let's see what current character is. Current character is R, right? So when we were on R, what happened is object at R, which is 11. Is it greater than most common count? No, because the previous most common count was 25, right? So 11 is not greater than 25, so we go into the else if statement. And let's see, so far we have the second most common count to 0, and we're asking, is that less than the most common count? True, right? 0 is less than 25. And then we're saying, okay, is the second most common character, currently 0, less than the object at character R. Again, object at character R is 11, right? So both conditions were true here. 0 is less than 25, and 0 is less than the current character count, which is R. So we do next, and then we find that we go into the else if statement. We run that. After that, we can see that now the second most common count is R, or in this case 11, which is for the character R. The second most common character so far will be R. So we can just keep going. Now character, let's do one more time. We went up. Now character is F. Yep, Khadija. Sure. Okay, so Khadija is mentioning that because if we get here, which we will add in the first iteration, why do we need this second condition or the end if we know that most common count would already hold the value of object at char, because again, at some point in earlier, or in the first iteration rather, it already went here. So yeah.
I was just thinking maybe just to get past the first value of zero. So it starts off at 0, then you have
I would say let's try it. I think Khadija's point makes sense. I think regardless we will always get to this point first, but let's try it. So the question is, would it work without that and condition? Let's create this here. Let's try to run it. Oh, now we have Q1. So maybe what Cam was saying. Wait, you meant this condition? This is the second conditional. Comment this one out. I see. So this one, bring it up. Like that. Is the second most common count less than the current character object? That's it. It works. So Khadija discovered a way in which we were being redundant here, and we can get rid of that redundancy. So let's revisit here what was going on. So second most common count is less than the object character, the object at that current character. Right, because if it would be greater, or Otherwise, we would have met this condition. We would have met is the count of that character greater than the most common count? Right? If it's not, then we go on to the else if, and then we just need to check, is this character less than the second most common count? No, greater than the second most common count. Right? Because the second most common count starts at 0. Basically, with the first condition, we're verifying if the current character is greater than the most common character. And with the second, we're asking, maybe if we write it this way, is the current character greater than the second most common character? Maybe written this way, which is, first we're the current character count, is it greater than the most common character? If it's not greater than the most common character, then we want to check if it's greater than the second most common character to keep track of it. Does that make sense? So in the beginning, let's try to run it again. Let's see. Still works. Now let's try to run it with the debugging tools here. So again, the first character is W. The most common count is 0, so the most common character so far will be W, right? We haven't seen any other characters. The most common character count will be 7. We go on again. Now we're checking is the count at key E, 25, greater than the most common count, 7. That will be true, right? 25 on the left side is greater than 7 on the right side. So we go inside the if statement. We update the most common character now to be equal to the E. And then we say, okay, the most common count, now update that to be 25. Now let's see what happens next. Now, most common character is R. And we saw that we went to the else statement because, well, object at R is 11. And 11, is 11 greater than most common count? Is 11 greater than most common count? Right, no, false. We go to the else if statement, and then we ask the second question, which is, okay, is the most common or the current character count greater than the second most common count? In this case, is the current character count, which the current character is R, is the count of R here, 11, greater than the second most common character so far? True, it's true. 11, R11 is greater than 0 because second most common count started at 0, right? So here we're saying 11 greater than 0, true. So we go in, we are console logging, we are saying, okay, set the second most common count to the count of the current character. Now that'll be 11. That'll be the count of R. And then here we can see that now second most common character was updated to R. Is this making sense so far? A little bit. Okay. Let's see what happens next. Now we go back to the loop. Now character is F. Is the count of F's greater than the most common count? I don't know. Let's look at it here. F, we have 5F. So is F greater than the most common count? No. Right? 5. The count of F's is 5. So 5 is not greater than the most common count because, well, we saw that E has 25. So we jump to the else. We ask this other question again. Is the count of the current character f, which is 5 as we saw here, is that greater than the second most common count that we have seen so far, which is 11? What's the answer to that? 5 is not greater than the second most common count, right? The second most common count is 11. Yeah. Mm-hmm.
It becomes 11 there, the actual why. So the first example, you said it's not because it's repetitive. This case doesn't become 0 anymore.
Right, because I updated it here in the previous iteration. I updated second most common count. I updated it to 11, which was the count of R's. Here, it was this count. The count of R's was not greater than the most common count, which is 25. So we don't run the if statement. We go to the else. Now we were asking, is the count of else greater than the most common count? What's the count of else? 7. Right? Is that greater than the most common count so far? The second most common count so far? No, because the second most common count again is 11, and that was for the R. So we don't run anything. We go back to the for loop. Now character is O. Is the count of O's greater than the most common count so far? Count of O's is 19. The most common count so far is 25 for the E. Is this statement true? No, right? It's false. So we go back, we go to the else if, and now we do this other question. Is the count of character O greater than the second most common count? Right, the count of character O is 19. Now the second most common count so far is 11 for the R. Right, so now here we're saying 19 greater than 11, true. Go in, console log, then reassign the value of second most common count to be from the previous value, which was 11, to the current character count, where the current character is O. So we reset that, we reset second most common count to the new value, and then we say, okay, second most common count now, instead of being R, because now we saw that O is the second most common character, we replace that and we overwrite the R and we put the O instead. Now, if we look back at our variables here, this most common count is still E, and it will be forever in this string with 25 occurrences. The most common character that we have seen so far is O, or the second most common character, sorry, will be O, and the count of that is 19. Now, if we keep just doing this, we're still doing that check. Now we're on character G, so we're down here. But we see that we are never going inside the bodies of neither the if nor the else, right? Because, well, let's do one check, random check here. We're on T. T17. Is 17 greater than the most common count? No, it's not ever going to be. This most common count is 25. Now we're checking the else if. Is the count of T's greater than the second most common count? We have 17 T's. Is that greater than 19, which is the count for O's? No, so we just keep going. And we end up, once our loop ends, let's see what character are we currently going on. We are going on character C. We're almost there. What character are we on? V. The last one, Q. Now we go here and we console log the most common, and we're going to console the most common count. After that, we console log the second most common count, and lastly, the second most common. Well, here we console log the second most common character. Then after that, we console log the second most common count. Joy?
Problem in the first instance,
If
the problem is 25 lines, so
right, so let's try. You mean let's try to make C the most common character artificially. Let's set C to 30 and let's try our program again. So let's do that in here. Object at character C equal to 30. So we artificially change our count to be equal to of C to be equal to 3, just because, and this is good programmers thinking. Joey mentioned, what if the count is not so early? I'm just curious about what would happen, and you want to test your program under those conditions to just double check. Okay, let's try that. Let's console log now, and let's see if C is 30 now. Oh, we have a bug. So C will be 30. Artificially, we change it to 30. But then my program is just telling me that the second most common count is 19. But the second most common character should be E. Good catch, Joy. Good catch. We have a bug. So if we have 30 C's, then the program doesn't work. Bugs? Say that again? It's because it only loops once and it goes through the entire thing. Well, we still want, in this case, we still want to only loop once. We shouldn't have to loop more than that. Yeah, Joy? Yeah. Right, so here you're saying before I set the most common character to the new common character, I should say the second most common character is equal to whatever the previous one was. And the same thing for the count. So what I'm saying here is we should keep track of whenever we're going to update the most common character, keep track of whatever the most common character was before we update that. And I think this was, let's first see what we get. We still get 19. But let's see what we have in comments. Has to be E now. Oh, it says the count is. Oh, this is correct. Right. Thank you for that, Sergio. Oh, it does. It works. So I think at the beginning this is sort of what I wanted to arrive to, but I was thrown off. I just got confused about that being actually working, and we ended up going the other route. But let's see if it still works with the original. Would it still work? What's your take on it? That's all. Now we have W7 and the most common character B. W, we have the most common character to be 25. Right, that makes sense. But the second most common character now is W. So I think what we need to do here is before updating the second most common character, actually, any suggestions? My brain is gonna fly. Yeah. But it shouldn't be crazier than what we have.
Okay. You want to find the fifth most common?
Okay. Describe how you do that. Like, you use a function that we haven't seen in class. Let's see Michael's method.
So first, these two right here are from earlier problem.
Okay.
It just gives the value. This is from the array map. And then this is for the last problem. It was small before, but I just before it be A minus B, I just gave it for B minus A, and then I give it in the reverse order. And that gives a lot of 6.
Okay, and then this one is the one we're doing. The most common letter.
Then
but then, yeah, but here you're doing the red text. We should. I have a suspicion that we don't need to loop again over the original. Sure. Okay. Right, I'm expecting your code here. Oh, I guess fix that one. Wait, did I take this out? Sure. Then I'll say. Okay. Okay, I got it. I think this was what we just did a few minutes ago. Let's say.